Okay, so I'm going to get started. So welcome to this month's edition of Big Data Bellevue. We hold this meetup once a month, and we've been doing it for the last 5+ years. So it's been an evolution of big data related topics. Again, my name is Siddharth Agarwal. I'm the organizer. My co-organizer is Chaitanya. And I work in big data. I've been started with Hadoop, and now I'm doing big data analytics in the cloud. But this meetup is typically attended by a wide variety of folks, some beginners, some very experienced, and our talks also vary, with some very specific and some pretty general. Today's talk is overview, an introductory overview to data science. That's why it's called Data Science 101. So we hope that folks are curious about it or interested in a refresher about, what is this data science all about. To get started, I'm going to just go through our list, since we have a fairly small list of attendees at this point, and have everybody just say their name and their interest. So I think I'm done. I'm going to hand it off to Chaitanya. You go next.
Thank you, Siddharth. Can you guys hear me?
Yep.
Okay, hey, this is Chaitanya Dapke here. I'm the co-organizer, been co-organizer for 3-4 years now. What brings me to big data meetup is definitely my interest in big data, in data mining, and what the new stuff is happening out there, and also definitely meeting new people and what's happening in our community here. So it's good to have Jish here again presenting. Maybe it's his second or third time with us. So thank you, Jish, for coming and presenting. And yep, that's all from my side. Thank you, Siddharth.
Thanks, Chaitanya. Hani Patel, could you just give a quick intro?
Sure. Can you guys hear me okay?
Yes.
All right. Thank you for arranging this webinar. My name is Hani Patel. I've been working as a data engineer, BI engineer kind of role in the organization. What brings me to this meetup is similar interest, and I also want to grow myself within data science AI community. That is one of the reasons. Another could be just networking and meeting like-minded people. Thank you.
Great, welcome. Jay Wickland.
Hi, can you hear me?
Yes.
Hi, great. My name is Jennifer Wickland. I'm a CPA. I am principal at my firm, and I direct Sound CPA Insights at Sound Accounting and Technology LLC, which is in Bellevue, Washington.
Wow.
Thank you for the presentation.
Yeah, thanks. Welcome. Jeff.
Hi, everybody. I'm an engineer with multiple career paths. One was scientific computing and visualization, and I'm currently working in the area of automation, and I'm trying to marry the area of AI, deep learning, machine learning, practical applications, and it crosses right into data science. So I thank you for the education you're going to perform, that we're going to learn today too, and nice to meet everybody.
Thanks, Jeff. Welcome. So with that, I'm going to turn it over to Jish, who will give our talk for this month.
All right. Okay. Thank you and welcome, everyone. Thank you to Big Data Bellevue for giving me this opportunity once again. So my name is Jish Nath, and I have been in this area for at least 25 years now. Most of my time I was with Microsoft, and now I'm independent. My main area of interest is, of course, networking and really understanding how to make data science practical and how to make data science usable. So when Siddharth reached out to me, that was very much top of my head, and we just talked maybe less than a week ago, or even maybe much less. So I said, you know what? Let me present a data science 101. Let me set the stage, because I know there are a lot of technical topics, but seldom we have an opportunity to kind of bring everybody on a level playing field and get the same understanding. So that's why I thought, okay, today's topic is going to be a much general, broad understanding of what data science is. I'm going to focus on at least what I consider as the minimum of skill set that you need. And then you folks should decide, A, whether that is something you can take a bite on. B, if you do decide to take a bite on, then how would you make this relevant to your own practical use case? Because I fundamentally believe there is data science waiting to happen everywhere. Okay, so like I mentioned, so my foray into data science or AI actually was, I was doing list programming back in 1993, more from an academic standpoint, then got into automation, then traditional data warehousing, into data mining, and then, of course, anything and everything to do with data, whether it's data engineering or data analytics. I happen to also be a part-time teacher with Seattle Central College, where I'm focusing more on making data science available for particular use groups, such as finance, such as manufacturing, HR, marketing, etc. So anyways, so today it's a broad topic. So what I'm going to do is I'm going to sail through the first few slides, because those are really, really basic. And then as and when the material builds up, I'm going to make it a little bit slower. So I'm going to talk about some of the background material and the trends that we see in 2021. And it really doesn't matter what industry you're coming from, what vertical or what horizontal you're coming from. Like I mentioned, there is data science opportunity, there is machine learning opportunity, there is artificial intelligence opportunity, pretty much in any corner of the world. And so what we need to be cognizant is, it's not that data science needs to be only concentrated to data scientists, but I think practically any staff, any professional will need to have some sort of this background material just to improve the company's performance or their personal performance. So that's why this is kind of, those are the minimum skills that I talk about, and that's where I'm going to be spending most of the time. And then hopefully, if I have the time, I'm going to lead you onto a path or a framework that we are developing, where I can mechanically teach you how to become a data scientist. It doesn't matter whether you're coming from a CPA background or an architecture background or even medical science. Okay, there are a couple of steps where, if you follow those steps, which is why that's a framework, because that can be repeated. And then we'll leave some time for Q&A. And if we do round of Q&A, please reach out to Siddharth, reach out to me, reach out to Chaitanya for any questions that you may have. Okay, so what is data science? In its absolute simple definition, data science is something that will help you to predict. It is identification of predictor of performance. Michael Lewis wrote this book called Moneyball, where he was strategizing how to have a winning performance in baseball, and he was analyzing various, different variables, and he focused his studies on this coach, and he found out that there are strategies that are happening on the field and off the field. So, in real simple terms, he analyzed what's the Oakland Athletics team's cost per win versus Yankees cost per win. And therefore, if you can come up with a model where you can predict what the cost per win is going to be, then even with a tighter budget, you can have a better result. So this is data science in a story format, but I believe that is pretty much the crux of the story, is anywhere you can perform better with a predicted value. So that's the key ingredient, is prediction. Now, you probably have heard of business intelligence. Just to recap, what then distinguishes data science from business intelligence? So if you look at these two axes, where you have what is my business value from low to high value, and what is the time frame of my analysis from past to the future, data science and business intelligence, they are kind of grouped separately. Business intelligence is all about, hey, can I know what has happened? Can I describe the past? Mainly it is used for management reporting, as you probably are already using, right? You have sales, you have any revenue performance, you have click-through rate, you have bounce rate, anything and everything that has happened, that's BI. And we've been doing BI tooling-wise since almost 2003 end. Microsoft has business intelligence accelerator. It was not even a product. And now we have a whole host of products. It's called Power Apps. It's a power suite of tools, and they have connectors to many different enterprise applications. On the other hand, data science, by nature, as we talked about, it is predictive. It is therefore prescriptive. So not only is it predicting, but it just doesn't leave you hanging with predicting, but it also helps you understand what are the prescriptions that are coming out of that analysis. So that you have to keep that in mind, as to there's a distinction between BI and data science. Also, the level of questions, the maturity of questions, they also become harder or more mature from a BI to a data science. In BI, you're asking questions like, hey, what were my revenues? How much fertilizer did a farmer use last planting session? Or how much downtime I had for some equipment? How many workers did I use last month, etc. Coming from that descriptive analysis, we are slowly going to go into data science, and we are going to start asking questions such as, what is likely to happen? What will become my revenue? How much item X are we going to use? What will be my equipment downtime? So the tense in that sentence will actually change. So when you are interested, or if you are interested in data science, people will judge you based on your BI frame of mind or based on your data science frame of mind. And then comes the hardest. This is where, let's say, McKinsey, their median, I would say, project size is probably $5 million. So they're not only just predicting what the values are, but they're also prescribing what actions to take. And this is most near and dear to me. Data science is worth zero if you do not know what to fix or how to fix, not just what to fix, but how to fix. And that's where you need to know the algorithms, because you need to know the variables. You need to know how you're modeling things, such as, can I plant the X and Y crop across different, across from each other? Can I pre-order an item because I can get discount? Can I have a predicted maintenance for all of my equipment? And then if I am expecting a higher revenue, then can I hire certain number of more workers for, Y number of days? So keep in mind descriptive, predictive, and prescriptive. So far, so good? Okay. So this is just keep in mind, this is only for your back pocket. If you're looking at BI job versus data science job, as a BI, your responsibilities are going to be more reports, more KPIs. In data science world, there are really not such static or fixed outcome, mainly because you're exploring, you're experimenting. So things are not going to be that repetitive. For instance, I'm going to analyze how many people are attending the big data conference or seminar or talk every month, right? But because there are so many variables, there is time of the day, the day of the week, different educational qualification, different professional background. So there are so many variables, and by the time I'm analyzing all of these variables, there is really not a fixed pattern. So I need to be a little bit amorphous on the data science. So same thing with the data sources. They're pre-planned on the BI side, but on the data science, it's a little bit on the fly. And I keep telling people that in addition to having, making friends with your data science people or team, you also need to be making friends or befriending the data people, because these are the people who have to grant you access to data, be it Google Analytics or be it SQL, whatever that case may be, because even they don't know what to give you, so they're probably going to give you read access, and you have to probably come up with your own schema on the fly. So there are, different qualitative variables or transformations. Again, things are, or manipulation, they are carefully planned because it's a very static format. Every month you're gonna produce that management report, versus data science, there is, it's on demand. Data quality, there is single version of truth on the BI side, but on the data science, it's good enough. Schema on write or load. So when you're loading the data, that's when you are investing most time to actually create the schema. Schema is the technical design of how your rows and your fields or your columns, what is going to be your field length, what is going to be your maximum row length, therefore your database size, etc., etc. So that's all schema. Whereas on the data scientist, it's a data when you're trying to query. Okay, so data is not completely locked. You just load first, and then you are going to find out or figure out what the user is demanding at that time. And last but not least, as we talked about, BI is retrospective, and data science is predictive. So what I'm going to do is I'm going to first cover some of these algorithms, and then if we have time, then we're going to come back to it. Before I do that, there is a reason that inspired me for this chat tonight. Is there is a significant trend that is brewing for 2021, 2022. You may already know, you may not. There is a significant investment that is coming up. Almost $100 billion in the next year. Just in 2021, 2022, this this season or couple of quarters alone. That's significant. So from 3.9-ish trillion to 4.1-ish trillion. Okay. Next, that I keep hearing, and those who are taking an interest in the job or upgrade your skill, AI as a service. So there is an AI as a service that is going to explode. And it is going to be not just data, there is going to be data, human intelligence, and AI. So supervised, unsupervised, combined on the data. So this thing is going to explode, and people are going to be either consuming those kind of services or putting them in the marketplace for those services. So for those people who are looking for jobs, this is a great time to be investing in this field of knowledge. And I'll talk more to it as to where the demand side is. So this is the growth side. This is, sorry, I'm going to talk about the supply side, but this is the demand side. Then there are regulations on deepfake legislations. So deepfake is how you analyze videos and call qualities and images and audios. So as you know, that people are faking these data, they are kind of morphing, they're coming up with videos of people who actually they did not make. So the government is putting very serious restrictions on these deepfake media or deepfake advertising. So there's going to be people that they need, companies need to help them with this kind of deepfake prevention, if you will. Then there is federated learning. Federated learning means you have your devices such as mobile, such as, let's say your iPhone, your iPad. You're just going to download the model, the algorithms that we are going to talk about pretty soon. You're going to download it from the server, but you're not going to release the data into the server. So the data remains sovereign. So the data remains in your device, which is a big safety relief, if you will. But you're going to talk to the server in fine-tuning your model. That is the concept of federated learning. So the growth is extremely spiky. However, there is a huge shortage in the talent pool. Okay. Just to give you an example, so the data scientist is ranked #1 pretty consistently in LinkedIn. It has a job score of 4.7 with a job satisfaction of 4.3. That alone is a pretty high rating. There are 6,500 opening, and this is not just PhD data scientists. This is just anybody and everybody. And I think this is a great, because the demand is so high, people are willing to teach you and to send you to training to become an analyst, even if you don't become a data scientist per se. Okay, the median salary is pretty high. It's pretty decent. Okay, and the government is also predicting that there is an increase of 28% till 2026. Now that is a robust growth. I don't know whether US can meet that demand. Right now, US is leading Europe and China and India. So bottom line, demand is far outweighing supply. Any questions or comment? Anybody that is looking at this in this field? Okay, so now let's talk about at a minimum what you need to do, what you need to know, whether you want to apply for data science or not. We have all seen this. We have all seen graphs like this. We've all used Excel. We have all used Google Sheet. So the main premise of this is, can you do a trend analysis? A basic trend analysis does not mean that it is linear. So the point of my slide here is you should know how to fit different algorithms, whether it's log, whether it's polynomial, whether it's moving average. So you should, at a minimum, know how to do a trend analysis given any series of data. That's the crux of this slide. The next slide is, if you have seen, and one caution that I should make is, do not pay too much attention on the X and Y axis, because your use case is going to be different. And sometimes these are obfuscated for privacy reasons, but do take a look at the shape, because as data scientists, you do need to know the shape. You do need to know that what is the nature of the variables that I'm trying to analyze. So in compound trend analysis, you are trying to then pick many different variables against time. Trend is just one variable against time, but then you're going to peel that onion and you're going to say, okay, let me then understand all of the variables, how they vary over time. So this is where you're going to have a composite of graphs, and you're going to analyze, is there a trend of all other variables, not just the output variable, but all other variables, shall we say, independent variables with respect to time. That's what compound trend analysis means. So keep in mind, you got your basic and you got your compound. Okay. So then what comes in handy is you do these trend analysis and you name your trends. Okay. But the main idea of a trend and data science is to predict. So in order for you to predict, then you must have an equation. So in this case, ultimately, what you will need to do, of course, all of my slides are unfortunately, or many of my slides are verbose. So I will not be able to fit it into this chat, but I'm just kind of giving you what is just the crux. Ultimately, you need to form an equation, or you need to learn how to form an equation. Oh, by the way, all of those calculus and linear algebra or nonlinear algebra, you do not need to worry about those things anymore. There is Minitab, there is Excel, there's so many, you don't even have to be a Tableau expert. Even in Excel, you can get all of these equations fitted, okay? So do not let the math stop you, okay? But the main thing is you do need to come up with the equation so that you can put the X's and Y's, because you need to put the future X to come up with the future Y. That's your goal, the future Y. You have to predict Y, okay? So that's what the trend analysis ultimately comes in handy. The next is box plot. Box plot is, it gives you not just the central, what in statistics we called, what is the central tendency. So, hey, Google, you're giving me tens of millions of page views, okay? That just happened last week. Okay, is there a central tendency? Is the data forming around certain average? That average can be a mean, can be a median, can be a mode. Okay. Now these are just these are different ways of understanding the behavior of the data. Is the data arithmetically mean, which means, hey, I have so many so many numbers and I have so many counts, and can I get an average where it stands? Or if I line up all these numbers, can I have a knife and cut that line into half and say, this is where half of my values in the line That's my mean, that's my median. Or there could be mode, which means which of these data is occurring the most. Okay, so we have mean, median, and mode. But when you give people just an average, it's not good enough. You also have to tell people how dispersed your number is, or how noisy your number is. So box plot, the beauty of box plot is it just in one shot, okay, it gives you what the median value is and how dispersed the distribution is, or if there are any outliers. Okay, so in this case, this is the case where we are studying knee replacement surgery by surgeons. We have different surgery type, and then we find out, what is the average cost by surgeon. So this is kind of taken from the class exercise that we do. So box plot is going to be a very, it's going to be a quick and effective tool. Very easy, yet do not underestimate, just because it's easy, it is very effective in trying to gauge how dispersed your values are. Geographic distribution, this is, you have all seen it, in pandemic especially, you can see different trends, that is, or you have seen it in weather maps. You have seen when a tornado is brewing, so you can see the trend over time. You can see, in this case, we are seeing certain accidents that are taking place in the East Coast, and we are trying to zone in how these accidents can be prevented. Okay, so we do have a pattern, then we go deep, and then we come up with some predictors, and then we find out what of these predictions we can influence, therefore we can reduce accidents. So this is what's called a basic trend analysis. Now it's going to, so let's talk a little bit where it's going to be, you need a little bit of marination. Okay, so this is like, very basic staple food for data science, scientists, I should say. The next one is going to be also you need to keep in your back pocket, which is called a pairs plot. So you remember we started with a basic trend analysis, then we did a compound analysis. Compound analysis, the x-axis is still the time. The y-axis is different variables. Okay, in, let's say, who attends data science or who attends big data meetup. There could be gender, there could be education, there could be zip code, there could be employment status, there could be, so many other factors. Those factors are all trended against time in a compound analysis. In pairs plot, it's not against time alone, it's against each other. Okay, so here the main idea that you need to remember is you are going to vet different variables against each other. Those variables may seem benign, they may seem completely independent, but you still have to vet it. Okay. For instance, I did an analysis where I'm understanding when does a sales team lose a certain sales deal. So I have, let's say, over 10,000 such data, but each data has 200 fields. Okay, it's physically and humanly not possible for you to understand the interactions of all of these variables within each other, not just to the deal failure or success. Human beings can at most, the smart ones, the genius ones, can at most compute 6 variables at a time. But the computers or the software can actually come up with several such iterations, okay? So you don't need to know how to do it, you just need to know how to use the software to do it for you. So the software will then give you multiple iterations between each other or amongst each other and will give you, hey, is there a strong relationship or not? That's what you need to know. So the red ones I've marked where there is. In this case, we are looking at emergency visit of patients, right? What makes that traffic go up or down? Is it because of pandemic? You know, is it because of snow, rain, or accidents, etc.? So you're going to plot these between each other. So 5 variables against 5 variables, and you're going to see, are there meaningful relationship? Meaningful relationship is something that has a trend, any visible trend. Okay, so that's something you need to know is pairs plot analysis. So today we are not actually talking about the use cases. The use cases are aplenty, right? But I'm teaching you some of the basics of algorithm where you're going to use it in any different, any or multitude of use cases. So the next thing is picking up a notch. So now you have time series decomposition, which means, again, you are analyzing based on time, this time, except this time, now you are, or your algorithm is sophisticated enough to spot certain recurrence or spot certain periodicity. The periodicity can be cyclical, okay? It can be seasonal, or it can be random. So ultimately, your job is to find out if there is any pattern in that time series, okay? So we call it a time series decomposition analysis, okay? And once you see cyclicality, okay, you are then going to find out what is causing the cyclicality, okay? So if big data meetup attendance kind of goes up and down, and it's not seasonal, so what makes certain or certain talks attract more collection of users or audience? So that's where you're going to find out, are there any conflicting events that are going on? Are there industry trends that are coming up? So you're going to find out what is causing this cyclicality. Make sense? Any questions so far? Okay, so the next we're going to talk about some of the, so these were just the simple plain vanilla algorithms, okay, that you as a data science must know that you may or may not have been completely familiar with in your BI world. You may be, but you may not be. But now we are definitely going to talk about some of the advanced models, right? So some of the advanced model, you have to know there is a, especially in AI, there is math involved, but don't worry, of course, the math is being taken care of by the software, but at least you should know a basic level statistics and basic level cause and effect. So cause and effect is the correlation and regression. So that's something you need to know. At least you should, you need to know a little bit of probability, and then you need to know the chi-square test, the goodness of fit. Okay, that I would say any aspiring data scientist should have and even if you're not a PhD data scientist, and even if you don't care about that, this is coming, okay, in every sphere. If you're touching data, sooner or later, you are expected to know some of this thing back of your hand. The next thing is the deep learning, which is what we talked about, right? So deep learning is all about, this complex data recognition, voice recognition, image recognition, handwriting recognition. This is part of the neural network, and this is, definitely, like I said, this is a significant investment that's coming down the pipe. There is also supervised machine learning. So in the analysis world, there are, you can have 4 quadrants. You know what you know what you don't know what you know, and then you don't know what you don't know. So these are different, these are more of axioms, if you will, how people divvy up relationship within data. So when you talk about supervised machine learning, that means you know something more than the machine, okay? You know what you don't know. You know that you need to find out how many people are going to show up next big data meetup, okay? You know that you need to find the attendance ahead of time. So that is what you're trying to find out. That is the unknown. But you are going to supervise the machine. You're going to supervise the learning. You're going to train the machine so that it allows you to come up with the learning part. Then there is unsupervised learning, which is, that's where I'm going to talk about next, is clustering and association. These are the hidden gems within the data. And then there is, last but not least, there is reinforced learning, which is the machine keeps on learning itself. And as we talked about federated learning, that is the whole, the gist of reinforced learning, where devices are learning themselves how to counter an attack vector, etc., etc. So real quickly, so what is a cluster analysis? Very simply put, if you give me 10 million records, okay, I know algorithmically how I can group these data into certain clusters. What are clusters? Clusters mean that the data in each cluster are more similar, and data across different clusters are more dissimilar. So here I'm intentionally giving you a pie chart, which is to show you it doesn't matter. The clusters do not have to be spherical shape. If you have number of clusters that are few and you need to deep dive into them, you can just have a pie chart. But of course, pie chart will become ineffective if you have tens and thousands of clusters. So clusters are variables that behave similarly, okay? So you need to know what is this cluster analysis. In this case, we are analyzing behavior at a casino, and can I have different clusters of players, okay? And here, as you can see, I'm aligning different clusters with they have their different statistical probability, and therefore I can then have a prediction as to which cluster is going to be more active on certain days or on certain machines, or be responsive to certain events. Remember, your job as data science is always to predict. This is just a means to that end. The next thing is a normalized curve equivalent, which is, if you have taken any testing method in the US, this was basically the genesis of that. When you have so much variety, let's say you have students with different height, okay? You can express, let's say, my child goes to grade 6, and there are some people, there are some folks who are 4 feet tall to maybe 5.5 feet to maybe even 6. I don't know yet. So from 4 feet to 6 feet, how can you express this in 0 to 100 scale? So this is where NCE does. It expresses your variable, your x-axis, into a 0 to 100 scale. And by the way, the gap between the data, they remain proportionate. Okay, so and very commonly we use it for movie review, we use it for restaurant review, 0 to 5, so everything is normalized nowadays, right? So that's what you have to kind of, keep that in knowledge, that this is going to come in handy. I'm going to skip this part, but real quickly, the NC score becomes handy because then again, you can classify the data. Okay. Next, you need to know association. So association is how two variables are impacting the outcome together. Okay. They tend to happen. So this is an example where taking credit card histories of customers. And in one particular customer, we are seeing that, hey, there is a huge association between Trader Joe purchase and Amazon purchase, Starbucks purchase and Chipotle purchase. Okay, so real quickly, you can have billions of records, but I can form not just clusters, but I can also find association of certain usage, okay, certain customers, certain products, certain events that they behave, they tend to act together. They tend to happen together. That's what association means, okay? The beauty of association is you then group these things, okay? You group these and then you find out, you create this association rule that capture this particular customer's usage or behavior. And then you create this common grouping, such as Chipotle and Starbucks could be one group. Marriott, Virgin America could be another group. Okay. Trader Joe's and Amazon could be another group. What's the advantage of grouping data in such way? The advantage of grouping such way is there is this concept of individualized promotions, an individualized marketing technique. That's where you are going to tear apart one segment of the market and individually address the marketing promotions technique. Next, we're going to talk about social network analysis. So each of these dots is a person. And in graph analysis, or SNA, SNA is a type of graph analysis where you're trying to find out, hey, does one dot create its own network around itself? So when you have that kind of a behavior, you can, we call these influencers or experts or subject matter experts. You're probably following them on Twitter or Instagram or Pinterest, right? So these are where graph analysis comes in handy. And as a data analysis, this is another very interesting, algorithm to master. The next is text analysis. Siddharth and I, we were talking that, hey, if I could analyze all of these data science topics, big data topics, then I can see a pattern. So text mining, it extracts some of these texts and finds certain groupings or finds certain frequency of how many times these groupings are occurring in a text. Okay, so text mining is another big topic of data science. Next is sentiment analysis. Sentiment analysis is we can gauge the mood, we can gauge happiness, anger, disgust, fear, surprise of the client's behavior as well as the client's competitors' behavior. So in this case, we have one client and we have multiple competitors, and we are trying to find out does the client have any particular advantage on the user's behavior, social behavior, mood behavior, okay? That's what sentiment analysis is. The next is traverse pattern analysis. This is mainly used in traffic flow. If you walk into a target, you probably have already observed that there is a very specific pattern. Whether you go to Target in California or Alaska or anywhere else, you will see that pattern. So this pattern is coming from a very deliberate design, okay? There are these rules that are then mapped on a geographical map. And then from a geographical map, they come out with a traffic flow, and then they say, okay, retail is going to be this side, grocery is going to be on this side, clothing is going to be on this side, and home improvement is maybe at the back, etc. So that's where if you folks or some of you are in retail, this may come in handy as traverse. And I think I have just maybe one more, and then two more, just real quickly. Decision tree classifier. So we have already talked about how data can be classified or how data can be clustered. The only difference between that clustering algorithm and decision tree classifier is you apply that clustering to a decision tree. So you already know what is the decision that you're trying to accomplish. Let's say we are not going to have a big data talk if it is less than 5 people, okay? Then you're going to find out for those 5 people, what are the variables? And you group these variables together and then try to find out how to influence. And then last but not least, this is the cohorts analysis, which means how one particular individual can impact the rest of the group, okay? How one person, how one machine can then impact within its cohort group, okay? And then given the knowledge of these cohorts and network, you allocate certain resources so that these cohorts can then perform to their maximum, because then they are going to be the influencers, okay? So this is kind of all the algorithms in a jumble, in a rapid fire. I do not know whether I did justice or not, but time is short, so I'm not going to talk about the next step. Maybe if you guys are interested, I'm just going to leave this on. This is the framework that I was talking about, thinking like a data scientist. Do reach out to me if and then reach out to Siddharth if there is enough interest. So what we do is, I've talked about the algorithm, right? But this then framework teaches you how to become a trained data scientist. I assure you, this no one talks about. People immediately jump into the nitty-gritty of algorithm, and then they lose hope. But this is a proven format. It doesn't matter what industry, vertical or horizontal. We have a framework that if you apply this kind of regime or this kind of discipline, you are likely to succeed. Okay, I'm just going to leave it there. And it has got step-by-steps. And then if you have any questions or interest, do reach out to me. There is, I believe, Siddharth, they have my email, I believe. So I think I might. So I'm done. I know it's 7. I'll take a question if people have time, and I'll hang around.
Yeah, at this point, I'd like to open it up to questions.
Anything.
Hey, just
Sorry.
Jish, can you hear me?
Now we can. Yes.
Okay. Jish, I was wondering, you were talking about AI as a service. Do you see any use cases, probably illustrate a couple of use cases that comes to your mind?
Oh, absolutely. The ratings and reviews, whether it's restaurant review, product review, right? So not everything is done by machine or by human. So what they're trying to do is they can identify what components are going into the next iPhone, and they can predict what the ratings are going to be on the new iPhone that hasn't even come out. No one even knows the blueprint. The blueprint hasn't been leaked out by Apple yet. And people have certain sentiment analysis going on as to how, whether it's going to be a hot product or not. And guess who's buying that kind of service? Apple. So this is an AI. It's a hybrid AI, but it's an AI. So anytime you're trying to launch a particular product, AI as a service is going to be handy. Same thing with marketing, right? With market, you're venturing into a new market. You do not have a data for it. Okay, education is a great example, right? So you do not have a particular market, and you're going into a greenfield, brand new venture. You are going to get into AI. You are going to have AI being done on your services and offering, and you're going to buy that kind of AI from different data providers. Okay. Yeah.
Interesting. Thank you. Another question came to my mind. Maybe I'll stay quiet for a couple of minutes if somebody else has a question, and maybe I'll ask my question after that.
Yeah, so I have a kind of a related question. So sometimes the predictions are correct, other times are not. So how do you charge these services for the AI for services?
That's where it is going to come up. It has to come down to what is called a confidence interval, right? You are going to give this a certain confidence factor that, okay, you are 90% confident, which means 90% of the time it is going to be within a certain bound of data. But is it 100% guaranteed? No. Even Microsoft cannot give 100% guarantee on the machines running. So there is going to be several tiers, and that's why it is still I would say it is an up and coming, and you probably have to tier it out as to, do you want higher confidence or lower confidence? Oh, by the way, these confidence also changes, because as more data comes into the training set, your algorithm gets more improved. So 2 years ago, I just did a voice quality project where the handsets are supposed to, understand how good this call quality was. It's just like Skype or Teams or WhatsApp. So the algorithms are also learning. The AI is also learning, So yeah, you may not know right now, but it is also growing and it is improving. And you test.
Yeah, so that comes to my next question. It's a very good point you brought it up. Is since the algorithm is improving, when you sell the product, the final result to the customer, you only, I guess, selling them the data, right? In other words, the model. The algorithm belongs to you. You can reuse it for the next customer.
Most likely, the algorithm is yours. Zillow is not going to sell their algorithm to anybody, right? But Zillow can predict for a first-time home buyer. They do not have the data because this person is a first-time buyer, right? So there is no BI data. Yet they're using AI. In fact, I'm working with a person on a similar company. I won't name the company, where they're finding out who they can target their blogs, and they are completely going into brand new market segments. Okay, so yeah, so this is going to be, it's they own the algorithm, and they will not just sell you the data, they will sell you results of the data. So I can see several approaches. They'll sell you results, they'll sell you the data, they'll sell you results of the analysis, then they will also sell you the prescription, which is what to do with the data. That is getting into more of the McKinsey consulting type, what to do with the data. The first two, I think there is still 100 billion waiting for the next 1 year to happen.
Yeah, I think now I got your point. So because AI for services, once you improve your algorithm, you can go back to the same customer and get a negotiate a different contract and come up with a much better result. So
yes, absolutely. You can also do profit sharing that, hey, you only pay me if you win. So I win only when you win.
Thank you.
What else?
I have a separate question if nobody
Please.
else has. Sorry. So the time series you mentioned, a lot of times the spatial overlap with the time. You didn't talk about that. So you treat spatial and time as two different analyses, but they are correlated.
Oh, they are correlated. They are correlated. My point was, when I start analyzing, I quickly first want to do a time analysis as an independent vector. If that has any other correlation, that could be separate. But I first want to, check the trend. That was my point. Yeah.
Thank you.
Jish, is there any way we can predict when the pandemic is going to get over?
there are so many models, right? There are so many models. It all depends on the independent variables, right? Because now because the DNA is now morphing, what are the factors that are influencing that, right? So yeah, you may have a prediction, and that's why CDC has said, hey, no mask. But then that rule is also going to be challenged with the incoming new independent variables. So, your guess is good as mine, but they're saying June, right? I don't know. I would want my child to go back to school full time. Any question on, is it going to be applicable to your field, your aspirations, your career goals?
I think one thing to comment on what you mentioned, again, focus on the AI for services. I really believe, I noticed your bio, you mentioned you like home remodeling. And it's almost like each of us, we have our own talent, our own vision. How do we remodel our home? So you're actually probably giving us advice that we should follow our own instinct and with maybe 12 or 13 analysis model you have, and then come up with our own business model for AI for services.
That's a great point. Absolutely. See, when I look at data science, I maybe 15, 16 years ago, I was a technician, right? All I could think about is clustering, and I could do this variable and that variable. As and when I have matured in my own career, I've understood it's not just the technique, it's when to apply and why, because I have to stand in front of other architects and then debate why such model is better or worse. So as a data scientist, you also have to know how to present your case. But yes, you have to do your own homework. Today, I've just shown you, hey, these are the different tools that you can use in the kitchen. We have not talked about recipes. Completely separate discussion, right? All I'm teaching you, hey, this is a knife, this is a steak knife, this is a different, butcher knife, etc., etc. This is a spatula. That's all I'm teaching you today, or I went over. You have to use your own method. You have to use your own due diligence, your sixth sense, research, Google, to find out which one do you want to use. I personally would not rest on just one. I would use it and then cross-check. Am I getting similar behavior from the other one before I start talking to my client? Yeah. So that's a great point.
Okay, so I'd like to thank Jish for the presentation. I must say I even came across some new, I guess, analytical techniques in your slides. And so I think that was a very helpful overview. Of course, I'd love to know how to do all of those different analysis, but I guess that will be a topic for a different day.
Yes, for sure. I would love to.
Okay, with that, again, I'd like to thank Jish, and that's it for this month's Big Data.
Thank you, Jish.
Thank you so much, everyone. Thank you. Bye now.
Thank you.
Bye.